Hi, I am Dr. Isra Anantawarasin. Welcome to the second session of Big Data Analytics. This session is a bit long that usually takes 2 lectures to complete. However, since this is a YouTube video, I decided to combine the 2 lectures together. Anyhow, all sections will be bookmarked so you can watch, skip, or ignore any session you like. In this session, we will introduce ourselves to the field of data science. Then we'll move on to explore some data and data visualization techniques. All right, without further ado, let's begin. Data science. Data science is an interdisciplinary field that combines various techniques and methodologies to extract insights and knowledge from data. And hopefully, we can turn these insight and knowledge into a set of actions that could improve our business process, benefit, or scientific discovery. Data science involves using scientific methods, processes, algorithms, and systems to analyze structured and unstructured data, derive valuable information, and make data-driven decisions. The field of data science encompasses a wide range of skills and techniques from different disciplines such as mathematics, statistics, computer science, and domain expertise. To get an insight from a set of big data, all right, you don't just, run some algorithms or some tools and you get the knowledge or insight immediately. You start by analyzing the data, asking questions, obtain the insight based on the questions, and then once you know something, you might want to know some other things, and therefore you get back to the data again, start analyzing again, start asking questions again, maybe the same questions, maybe some other questions, and get more insight from your data, all right, and come back in a loop like this. And of course, data normally they just don't stop. Okay, you don't just take data from somewhere and then start analyzing and that's it. Usually, when we talk about data, all right, it is dynamic. So data keeps data keeps coming in all the time. Okay, you have new set of data, you have new set of records all the time, and then you can start analyzing again, getting more insight, more data, more analytics, and more insight, all in cycle. Let's have a look at my Netflix page again. All right, we see this that we have a lot of recommendations based on my profile. My recommendations of movies or series might not be the same as your recommendations. Here, Netflix obtain the viewer demographic from the subscribers, all right, the accounts, watched videos, and my reaction to the video. How long do I watch? Okay, how much I skip the film, and then how many times I thumbs up and downs. Okay, in the earlier versions of Netflix, you can even give your response as star. How many stars do you recommend the movies, or how many stars you give for each film or series. All right. Now, after they got all this information, okay, from me, from my brother who share the same account, okay, they got they got to know me or other viewers more, and then they can better recommend the most suitable or appropriate movies or contents to me or other or other viewers. Okay. Now, once they recommend this film or series, I start browsing, I start watching. Okay, and then they collect more data, more watch videos, more thumbs up, more thumbs down, more watch time, and so on. And then the system knows me even more and more and more. And it can recommend better movies, better films just for me. What do they get in result? Of course, more subscription. The longer I stick with Netflix, the more money they have, the more people stick to Netflix, the more money they got. All right. And here's the thing about Netflix, because they knew, okay, no, they know what movies or series, what kind of movies or series their subscribers like. So they can produce more of this content to get them hooked. All right. And they can, because they keep track of the watch time and feedback and responses, they can cancel any film or series anytime they like. Okay. And and if the feedback is good, they can maybe extend for another season. And this is what I meant by actions to create business profit. Okay, you don't just understand the data or collecting insights; you act upon that. All right. In scientific experiments or observations, you might need to observe to understand, but in the real world, in business, you just don't want to understand. You just want to act so that you can gain more benefit, more business benefit for your company or your organization. And the data that you get, okay, that could be a historical data, the data that you keep collecting for a long time, and the recent data that you have that you just obtained, and then combining these two data, you make a prediction. What should you do? Okay, what kind of stock should I buy? All right, what kind of stock should I dump? What kind of companies should I acquire? All right, or what kind of movies that should we recommend to our viewers or our subscribers? Obtaining data, acquiring data, make a prediction. These are the main tasks of data scientists. All right. But what kind of skills do I need, okay, to be a data scientist? Here is the list of, well, kind of small list of data science skills. You could have more. All right. You need to know where you to obtain your data. You also need to know where to get the data. You also need to uh, ask the right question. And this is very important. All right. You need to understand your business and domain, and you have to know how to analyze them. All right. Obtaining data. We're going to discuss all this later in this session, all right? But obtaining data is one of the most important part because you need to know where to get your data from. For Netflix, it's quite simple, all right? You just run your business, and when the user click this or browse here, and watch the review or preview, and all these reactions, all these actions that the user do, okay, even including watch time and everything, you can collect them from your database, from your application. Some other kind of data, for example, business data, all right, you can collect data from your transactions, or like how many people bought which kind of product, where do they buy them, when do they buy them. But not just that, all right, you also need you might need some external data as well. For example, during some grand festival, water pistols might sell very well, all right, and the cola might sell very well as well because it's warm, okay, but there could be some other things. See, this is the example of seasonal or external forces that could drive your sales, all right. But some other things like influencer, they maybe Lisa Blackpink, she tried a new product randomly. She just went to 7-Eleven, pick one product. Oh man, it's cool. And she posts that online in her Instagram. And then your sales boosted. All right. You need to know that too. You need to understand, hey man, I somehow this kind of candy just sold out. We don't know why. All right. We would like to understand what is the reason. Of course, if Lisa post this on her Instagram, you would know immediately. But sometimes this knowledge is hidden somewhere. There's no obvious events or obvious phenomena that explain that behavior. So in that case, you might need to obtain data from somewhere else as well. It could be stock market, it could be financial data, it could be political data. Now, You also need to ask the right question. The right question and what to get, that's pretty much come together if you ask me. All right. See, you know where your data come from. You need to know what kind of information that is interesting for you, for your business. All right. So you need to understand your business first. What are you doing? Netflix, for instance, they just want to drive their subscription, or that is their main income. All right. I don't know whether they make income from advertisement or maybe sell their license of their Netflix originals or not, but I don't think so. All right. The main income is from subscription. So you need to just it's quite obvious that we want to learn what our subscribers want. All right. But some other kind of uh, data, okay, some other kind of business that might not that might not be so obvious. For example, if you work for a private hospital, you might want to increase the price. Oh no, hold on. You might want to increase your profit. All right, because that's what the private business do. So what could you do? You want to have more patients, okay? Or do you want to drive more sales? I mean, per patient, like since they have just one service, they can just do more, or you just want to drive the price. Okay, for this kind of thing, it's different. You want more people to come into your hospital, or for the number of patients you have, you want to up your sales. Okay, or maybe the same sales, you want to up your price. For example, if you want to just drive the profit, okay, I need to figure it out first. What exactly are the factors that make the customer come back to my hospital? Okay, is that because we have a legion of high-profile doctors? Do they trust the doctors, or do they trust the hospital because we are renowned hospital, and whoever uh, are the doctors or are the nurses here, all our staff are top notch because they trust our brand. We touch our people or our brand. Okay. Or do we have the sophisticated facilities and tools and equipment? Okay, we can do microsurgery, we can do a sophisticated MRI scan. The other guys can do just CT scan, for instance. All right, or maybe because our service, our staff are just super nice and comfort and easy. Well, you need to figure that out. You need to ask the right question. But once you have the right question, you know, okay, what to look for, and these kind of things, all right, it depends in domain basis. You need to understand your business, you need to understand your domain first, then we can discuss in more in detail. Okay, are you on the right direction or not? Therefore, being a data scientist is not easy. All right, the task is tough. You need to understand your data. You need to understand the tools. You need to understand mathematics, statistics. You need to understand the business side of things. It is fun. All right, I guarantee you that. I like this very much. If I don't teach, I might end up being a data scientist because I like the nature of the job. And sometimes when you want to analyze big data, big chunk of data, when you want to analyze a lot of questions, when you want to answer a lot of questions, to answer a lot of business problems, um, you need the team of data scientists. Okay, so you might not be able to work alone, and that this team could compose of many people of different skills. As in any undertaking, starting big data operation, either collection, analytics, and taking action upon the insight. Okay, you can't just go and do it. You need a game plan, and this is the big data strategy. It's a plan to get valuable insight and a set of actions from big data. Okay, and there are several steps to do so. So let's start with step one: business objectives. Here, you need to know what is or are the goals or objective of the data analysis. Okay, you need to know what why you need to do it. Okay, see, once you know the why, you will figure out what you want. Okay, first, for example, we want to boost up our sales, and then okay, now which angle, what kind of data, where the data, what kind of data should be collected, where do they come from, in order to answer that question. In other words, once we know what we want, we can find the problems that we need to solve and the data that related to the problems at hand. It is quite obvious that data, big or small, can be a big help to the business. Okay, it could make you do better plans, making better decisions. Okay, better marketings, better profit, better benefit. Okay, internal improvements, cost reductions, better strategy, you name it. Still, all right, you need to make sure that everybody in your team, everybody in your organization have the same goal. They need to see the same benefit. You need to convince others and communicate your goals. You need to make sure that everybody is seeing the same goal. And well, it might sound obvious in the beginning, all right, but I'm telling you this, there are two problems that would be problematic when you actually want to acquire data. First, acquiring data could be a tedious task. You need to imagine that when the employee, all right, or the staff, they are doing their day-to-day work, all right. Yet, if you say, okay, please record extra data for us so that we can collect and we can analyze for some business goal, okay. This recording, okay, if it goes automatically, for example, if I work in 7-Eleven and I use this barcode scanner to scan product, this is part of my job already. So I wouldn't feel the extra work, okay, because there is no extra work. But what if I am a stock manager, okay, and then I have to record all the product that's coming in and coming out from my stock? And I haven't done that before. There was no recording. But then now I need to do extra work here. The first feeling that I would have is that why would I do that? I am busy already. I have enough things to do each day, and you ask me to do extra things. That here's the thing: I don't earn any of that. Okay, I do extra work for other guys. I do extra work for the analyst. I do extra work for my boss. I do extra work for the executive. What do I get? Next one: data sharing culture. A lot of organizations, especially big firms, okay, big organization, and the government agencies or state enterprises. These companies, all right, they used to collect data on their own. What I mean is that each department, each unit, they are doing their own work. Okay, they keep their own data, and they are not trained to share this data to other people. The reasons could be, this is my data. We collected that. We should be able to use it first. Okay. If you want to use our data, then you need to ask. There could be some formal paper. Okay. There could be some price that you need to pay. That could be okay. Well, you need to pay extra because we need to produce data for you. Therefore, we need to bill your department. Another reason is a little bit more complicated. If I want to give you the data, for example, I am collecting customer data. All right. I know that, okay, this customer buy this product, this customer buy the other products, and then some other department asking this records, the payment or transaction records. I could be reluctant. Should I give this department, should I give the marketing department my data? Or should I give the new team of data analysts my data? Because I'm not sure the data contains customer information. The data contains sales information. First, I'm not sure I can, I am in charge of this permission. I don't know whether I can give you, or am I allowed to give you that. The second is, it contains some private information, okay, either from us, some from our staff, or from our customers. I'm not sure whether I could give you the data. These kind of things, it has to be cleared at the beginning. Okay, you need when you request the data, you need to know, okay, who has the data. You need to when you need to tell them that why you need the data and how you are going to store it, how are you going to share it. Okay, because you can't just access the database. Maybe they're going to dump you the data, but if they dump you a set of data, it means that once the new data coming in, they will just have to dump the data to the new version of data for you again, and you're going to have some kind of synchronization problems. All right, so you need to talk about the technologies, you need to talk about the policy, and this could be, even more extra work. Therefore, you need to make sure that everybody knows why we all need to do data analytic. Okay, everybody has the same goal. Everybody has benefits, and even lower rank staff could get benefit too. For example, I collect the data. Okay, I do the extra work. What do I get? All right, the executive is gonna know. Can predict sales, can predict the customer behavior. But what do I get? You can say, for example, okay, you give us the data. We're gonna produce you the daily report, or we are going to produce you the weekly report. We can also give you some insights about your data. Okay, which product is going to sell well, which product are going to sell not very well, and which time. Okay, you can share the benefit, and you should share the benefit to everybody involved in the process or everybody in the business. You need to make sure that everybody understand that analytics and business means opportunities for everyone. Now, do you have the data? What do we do with that? All right. So I'm not talking about how we are going to use the data in our analysis. All right. That's quite obvious. But you need to know, okay, the content of your data a little bit. Okay, so there could be some privacy data. Okay, some of them could be really sensitive. Okay, so you need to be aware of the privacy issues or some other legal issues. What can you do with the data? Do you have permission to work with the data? Do you have to permission to access the data? Okay, and talking about this, who can access your data? This is very important uh, issue, right? Because even in your team, okay, where if you know that, okay, I'm okay. I mean, I'm allowed to analyze the data to generate a report, but who else can see the report? And most of the time, you don't have to care much about this, all right? But some data are very sensitive. For example, some health data, personal data, bank transfer, okay, something like this, or even some user behavior. If you can identify who belongs, which individuals make the transfer, or which individuals make the purchase, then there could be some legal issue that you need to be aware of. And this kind of data, you have to restrict who can see the actual data. Sometimes if you just see the statistics, okay, like, okay, who purchase milk in general, then should be fine. But even who, if you are able to identify the individuals, okay, who make which purchase, or who has this certain conditions, who has cancer, who has some fever, then this is very sensitive, and you need to be sure that if the data is kept safe. Along this line, you also have to identify the lifetime of the data. Again, some data are very, very sensitive to this issue. Well, in general, I would recommend everybody to keep the data as long as you could, okay, because the storage today is very cheap, all right. And in order to be able to analyze your data using time series technique, all right, you need to keep your data um, for quite a long time to see the trend, to see the behavior over time, all right. But some data, especially personal and sensitive data, all right, you need to understand how long can you keep them, and it goes both ways, all right. Let me just use some example. Um, if you are working in the healthcare industry, you might have to, okay, keep the patient's data for, if I remember correctly, 10 years. All right, this is how long the hospital should keep your data. And after that, it's up to you whether you're going to destroy it or not. All right. But I'm not sure about when whether after 10 years you need to destroy it, but you need to keep them for 10 years so that if there are anything wrong, okay, the regulators can come back and search through your archives. But sometimes the data are limited too, especially with this Personal Data Protection Act or PDPA. Okay, usually, okay, you need to declare when you keep personal data, especially the one that you can identify uh, the individual who owns the data. Okay, for example, name, first name, last name, the citizen ID, or any kind of data that can directly or indirectly identify the individuals. Okay, in that case, you need to declare what should you do with his data or her data, and how long do you keep them, and they have rights to remove their data from your database. Okay, so you need to have a specific data policy about the lifetime as well. After that, okay, how to clean and curate the data. This is more like the operational thing. Okay, you need once you understand your data, once you have a look at your data. Okay, this data field contains these data fields having missing data and so on. You need to have the policy, okay, to direct your team how the data should be cleaned and how your data should be curated or being maintained. And after you collect the data, you also have to have the policy to denoting or to specify how can other people use the data. And this is pretty much related to this point, who can access the data, but this is more like who can access the raw data. And if you want to export this data to some other organizations, okay, either the report, either the curated or clean data, maybe some filtered data, you need to be also think about what can you send to them and who can access such data as well. Before you start collecting data, all right, or before you even care about any data at all, you need to define the problem first. Okay, you need to identify what you need to know. Okay, what, and then after you kind of ask yourself, could be briefly or roughly. Okay, all right, I want to know this. It could be something like, how can we increase profit? All right, and then you can move on to what kind of data do we need. All right, in case of Netflix, okay, the problem of how can we make more money. All right, how could we be more profitable? Okay, you can have questions like, okay, what is our main income? Obviously the subscription. So the question going to be, how can we get more subscription using the usage data? Okay, and that, of course, we have mentioned before. You want to know what the users like. Okay, and then you can produce more shows, and you need to keep them like correct, the right pricing, correct promotion. Okay, to keep them hooked, to keep them pay for the subscription. But it could be something like, okay, we want to be more profitable. How can we reduce the expenses? In that case, you're looking for other kind of data. You are looking for your expense data, salaries, or some other benefits, all right, that you can provide to your employees, or some other operational costs that you can cut. Okay, so again, financial engineering, you know this. Okay, go both ways. You need to maximize your income and also minimizing your expenses. All right, and that depends on the and the data that you look for may depends on the question that you are actually questioning. Now that you have the question, okay, now that you have the question, you need to assess the situation. What are the requirements of the problems? What are the assumptions and constraints, the resources, and then the cost benefit is whether it's feasible, okay, to obtain such data, to curate or to store such data. Would it be beneficial for us, okay? And along the way, you also have to take care of or taking concern of the regulations, legal issues. All right, so let me get you some example here. If you just want some subscription data, it could be quite obvious and straightforward. All right, you just look at your the collected data, all right, that you have, the clicking, the likes, the watch hour, and so on. And these kind of data may or may not already been collected already. If they are not, and you believe that if you know this, okay, you would know more about your viewers or your subscribers, then you need to tell the development team to put that uh, features into the web app or the Netflix app. All right, now in order to know that, of course, to obtain such data, to collect such data, if you need to implement some features to collect the data, then that it costs something, right? Then you need to weigh in, okay, how much do we get out of this, and would it make sense to invest on such feature? For Netflix, if you invest on these features and you can collect data in the long run, then maybe it's feasible. But some kind of data like demographic or some other thing, okay, maybe some poll that you can use once. In this case, you need to really think about whether it makes sense or not to collect the data. And in Thailand, there are regulations and legal issues that you need to take care of as well. Again, personal data is a very sensitive issue right now. Okay, if you collect the data that can identify individuals, you really need to 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 inform those individuals that, okay, we are collecting your data for these purposes, all right, and you can contact us to remove the data anytime you like. So you need to have some mechanism to remove the data, that data from your database as well. All right, and okay, and you also need to tell them, okay, if you are sending your data to third party, you need to inform them as well that, okay, we are sending your data to our partners. Example for this is the credit cards information. All right, you subscribe with a credit card. All right, and maybe you have experience, you have seen this, you have seen this before, or you experienced this before. Well, they can sell your data to some other companies like insurance or department stores or some other companies, third person. All right, well, it used to be easy. It used to be like written somewhere in fine print, like page 30s of your contract with the font size like 5, all right, saying that we are allowed to send your data to anywhere we like, to whomever we like. They can't do that anymore. Okay, today it has to be clear and loud, and you need to consent all of them. You need to keep them consent for all of these choices, and then you can just, well, you see, right now you can see better, okay, what do they do with your data, and you can always invoke those rights if you change your mind. Another example that I find interesting is that some companies, okay, like I can just say a financial company, when they want to use the data to do some analytic, okay, some trends, some maybe even AI training like ChatGPT, okay, they would like to use data from across their clients. See, Big Four, for instance, they are the consultant firm, okay, for many other companies. Now, here's this. No, in normal kind of contract, they cannot use their okay, if they're consulting two firms, A and B, or A and B are their clients. You can use the A's data, okay, to work on A issues, okay, and then you can use B's data to work on B's problem. Okay, whatever you do for B, you can use B data. But if you think that, hey, it would be beneficial for everyone, that you can combine two data together and analyze them together. Okay, it could be that company A is a media company. Okay, company B is marketing company, and if you just combine them together, you would know much more. In fact, depends on the contract, but most contracts say no, you cannot do that. Okay, or even company C that is in the same industry as company A. Okay, and you were like, okay, we can use the tactics or information on A to also improve C situation. Obviously, you can't do that. All right. So regulations, legal issue, contextual issues play a lot of important roles here. So you need to assess the situation as well. That the idea that you can do with the data, the insight that you can gain with from your data, are you really allowed to do that? Lastly, about the questions, okay, say that you have your goal or your questions already, okay. Next one is you need to define the success criteria, all right. You have your objectives, we want to improve profit, but how can we measure profit? Yeah, okay, fine. You can just say this quarter we earn this much, the next quarter we earn that much, and we can compare, quarter by quarter, year by year, or year on year. It is quite obvious. But if you want to improve, for example, your services to your clients, like you want to make them happy, okay, now then you need to have other kind of goals, where not just by number of how much money you have in your account. Okay, if you want to define your satisfaction for your services, how can we know that? Okay, can we measure by the average time that your client is using your services? Okay, maybe, for example, you work in a hospital. Okay, the shuttle service time is better. The shuttle wait time is better. If you work for Netflix, the longer watch hour is better. Okay, that means that they like the show, so they keep watching longer. You need to make sure. Okay, right from the get-go, how to measure your success. There are 5 main components in your data analytic campaign, all right? And they are all begin with P's. That's why we call them 5 P's. First, purpose. Challenges defined by the big data strategy, okay, can be specific analysis and hypothesis of business requirements. So basically, you need to know what you're going to do, why you're going to do them, all right? Next P is people, a team of data scientists with different kind of skills, for example, science or business domain knowledge, statistics, mathematics, machine learning, and maybe artificial intelligence knowledge. Okay, and you need skill in data management, programming, and computing to manipulate your data. Okay, and they're gonna discuss how can they obtain and analyze the data so that each member would know what are their roles in this data analytics campaign. The people could be just one. Okay, you can do all of that. In many projects that I have, I'm doing everything alone. But that kind of project is they are quite small, or maybe in of moderate size that you can still manage. Okay, but for larger data or some messy data, like the data that contains missing values, the data that are poorly collected, then you might need more people to help you achieve your goal. Once you have the goal and the people, you're going to need a process. A process refers to workflows or sequence of tasks that you need to do to achieve your big data goal. For example, data collection or gathering, data cleaning, okay, and the step of analysis and processing the data. This is where you get the insight or your knowledge from your data. And then visualization. This is the process where you report or show what you know, what the data have, okay, what kind of knowledge that are contained in the data to the audience, to yourself. And the process is usually defined by the purpose. It is dictated by what are you going to do with the data and the people in the team. Okay, big data process should be scalable because we are dealing with big data. Even the data is not that large. Okay, maybe it's just some companies transactions. You need to make sure that they are scalable. Okay, what do you mean by that? Scalability usually refers to how much can you automate your system, or how much can you automate your process. For example, if you manually clean your data, if you manually compute your data, this column or this field plus this field equals this field, if you need to do this by hand, you could always do that. But what if you need to redo it again next week? What if there are new data coming in tomorrow? Okay, you cannot keep doing everything by hand. You need to make sure that you automate all the processes or as much activities as you could. I'm talking about this directly from my experience. All right, if you are doing data for some researchers, okay, you collect the data like from year 2000 to 2020, and you want to know some insight from that, then that's fine. You can do that. Okay, you can do all manual process you like. It works in Excel or some other data platform, other data like toolkits. Okay, bam, you have this 20 years insight or 20 years projection. That's fine. But what if you need to do that for a company that have this data coming in every day? Like, for example, you are doing the analytic for 7-Eleven, for some banks, all right, for hospitals. Things change all the time. Data keep coming in all the time. You can't just, manually execute every task by yourself. You need to also think about how can it scale? How can it scale in time, and how can it scale in size? Because most of the time when you do data analytic, okay, you are testing your process, you are testing your hypothesis, or maybe even testing how things work in a small set of data, maybe 100,000 records, all right. But in reality, you have 10 million records. The things that you do with 100,000 records, okay, might not work when you work in the actual data. Of course, you try to automate everything. Let's just say everything is automated, but can you wait for the process time? Do you have enough computational resources to process such large data? All right, you need to think about that as well. And the size, okay, the volume and the velocity of the data plays important roles on the selection of the platform, as I mentioned just a few seconds ago. All right, you need to be sure that whatever you do, you have enough processing capacity to process the size, okay, and the speed of your data. And to make sure that the process is scalable, any process that you do should be automated, and that comes directly with the fourth P, okay, the programmability. You should employ the tools that are programmable and reconfigurable. What I mean is, in the process of collecting data, all right, when you want to import your data from somewhere, okay, are you doing it manually, or do you have a program or a script to collect the data? Okay, and then when you clean the data, when you swap the fields, when you compute any values, okay, when you find, for example, average, or maybe when you want to find, okay, which value is larger than the other one, something like this. Are you doing it by hand, or are you doing it by code? What if you want to change the configuration? What if you want to change the source of the data? What if you want to change some logic inside? Okay, I hugely suggest that you should have the platform, or using the languages, or maybe development applications that can do this, okay, in a way that you can change the values, change the rules, change the parameters later. Because again, data could change. You got new things every day, okay? Maybe your idea and the original idea was wrong, okay? And you want to adjust these parameters later. You should be able to do that. And those are 5 P's already. We got the sixth one for you, an extra one. This is your data product, or the insights or knowledge that are hidden or are obtained from your data. Okay. Showing these insights, okay, is also a very interesting step, very interesting process. Okay, usually we have this data visualization platform that can explain, that can describe the insights or the knowledge that you obtain from data in the very intuitive and interesting way. And we talk about that also in this course as well. Now, let's zoom in to the design process. Okay, in general, you can divide the data science process into 5 main activities. First, acquiring data. To collect or to gather the data. Then you prepare your data. You need to make sure that the data is ready to be analyzed, okay, in the perfect shape for analysis. And then you start analyzing your data. And then you report your findings, okay. The insight that you get from your analysis phase, you need to show them to your audiences or maybe to yourself, okay. And if you like, you can act upon the results when you learn something new and you know that, okay, we can improve here, this is what we know, okay, you need to do something about that. The first step, data acquiring, okay. You collect data from your source materials. Collecting the data could be from many kind of sources, okay. We can divide our sources into two main types, okay. First is structured data, basically from your database, okay. It could be MySQL, Oracle, Microsoft SQL, and so on. And this is the data that are pretty much classical. You know already what could be your what is the structure of your data, or what are the fields that you store your data, what are the meaning of those fields, okay, what kind of data type should be stored in each field. Another kind of data is much more complicated. That is your unstructured data, text files, Excel files, log files, NoSQL storage, Facebook posts, okay, or maybe images, videos, these kind of thing. You want to gather some patterns from this data. All right, these unstructured data are usually user generated. All right, and you can't really control how users are generated. I gave you an example already on a Facebook page, okay, not on a Facebook post. There could be video, there could be images, and if you want to know what this post is about, what does it say, okay? If it is written in text, that you need natural language processing, you need to understand the context, you need to understand the content, you need to understand the grammar and verbs and so on of the post. But that is much more simple compared to analyzing such context from images or videos. This line here is a simple Unix command, a Unix script, okay, that allows you to extract some patterns out of some text file. We will talk more about this when we discuss data manipulation with Unix. And sometimes when you can collect data from your from remote sites, okay, from other websites, from other social media that are not in your system. More importantly, depends on your question that you ask. Sometimes you need to pull data from various sources, from many sources, to answer the question, to combine the knowledge together. If you want to know this aspect and that aspect and that aspect, okay, this knowledge that you want could come from many places. So let me get you some example. This is windy.com. All right. It is a very interesting and interactive website that can display global weather data. But as you can see here, not just the weather information or forecast that you see on TV, if you still watch TV now, all right. Here you see the interactive map. Okay, as you can see here, between China and the Philippines, you have a storm coming in. All right, and all the wind in the region are moving toward this storm. Okay, now let's move into Thailand. Okay, well, you can see here we have like some wind, okay, not too strong, passing through our country, but not just wind, okay. We can have a look at some other things. For example, the temperature, okay. Let's zoom out. It looks hot right now, right? But in Africa, it's even worse. Okay, this is the Sahara, and in Europe, they're doing not too well as well. Okay, temperature is rather high right now. Okay, now apart from that, we can also have a look at the clouds. Okay, how thick is the cloud? Of course, in the storm, in the eye of the storm, the cloud is super thick. Okay, the wave. All right, this is how strong the wave is. If you are interested in, there are many libraries that can draw this interesting, we call it the wind barb, okay, maps. I mean the wind direction, the wind vector, and of course the wave vector as well. For example, wind display library from nowschool.net. Okay, the author is Cameron Beccario, or wind map from hint.fm. I will provide all the links in the description. But this is not the point that I'm trying to tell you here. As you can see here, all this vector data has to be from, oh, this is very interesting. Okay, let's just have a look at this, rain accumulation. Okay, this is basically means the how strong is the how, what is the likelihood of raining, okay, in each region. You can also see the live satellite image of the entire region. Okay, I find this very interesting and fun to watch. You can see this in the satellite of of entire planet. But the thing is, as you can see here on this menu, you see a lot of selections, all right, set of options, what kind of data you wanna see. But I mean, these data, okay, that is shown in windy.com came from different sources. Okay, so you need to collect data from all of the sources, but not just that. In each source, I used to do this with a project with the Royal Thai Navy. Okay, then I learned that just to predict the wind speed, wind direction, uh, precipitation, okay, or the oceanography information, waves and everything, the tides. In order to predict all this thing, okay, it they don't just come from somewhere. Right? No one's give them the number. The way they do is they install weather stations in many regions in the world, okay, that collect weather information, for example, precipitation, wind speed, rains, and then the data from all these weather stations across the globe will be combined and predict what is the wind direction, what is the temperature, okay, what are the chances of raining. Okay, so the data must come from many places. And as you can see, just to tell you whether it's going to be raining tomorrow, okay, you need to have data from many sources and a lot of brainstorm. And what could be your data sources? Sources of big data can be divided into following categories. First, you have the machine data, data that are generated by sensors or smart devices, people, okay, data that are generated by people or users, and organizational data that are generated during business transactions. Machine generated data. Machines can collect data constantly and indefinitely. All right. You can place sensors anywhere in the world, okay, and let them collect the data for you automatically. All right. We collect a lot of data like this all the time. In the other example, we use the weather balloons or weather stations to collect weather data. Okay, we also collect seismic data to identify if there are any earthquake or tsunami somewhere. All right, you can also have smart devices or the devices with sensors. Okay, sometimes respond to what they sense, that can be integrated into your smartphone or into the smartwatches and so on. Machine data is therefore one of the largest source of big data because you can place them however you like, wherever you like, and they keep generating data all the time. The key challenge is to connect the smart devices together, and the field of study to connect the devices or sensors together are the fields of Internet of Things or IoT. Machines do generate it. Machines do generate data all the time. All right. The challenge is to acquire the data in the way that you can handle them. But once you collect the data, manipulating the data, reading the data, interpreting, visualizing them are not that difficult because it is machine. Okay, anything that they send, any data that they send are already in specific format, the format that you know, the format that you want to store. Okay, so interpreting the data, working on them is quite easy. But what is not easy? People generated data. Well, the most intelligent animal on earth, human, are the real pain in your butt. All right. We generate a lot of data too. Okay. Our social medias, our photo posts, cloud backups, what are, maybe Facebook or whatever service are listening to what we are talking right now as well. I'm sure you, when I post this to YouTube, YouTube will also collect my voice and video data and then process the context in background somewhere. All right. Still, people generated data are very hard to work with because most of the content are unstructured. Text messages, images, videos, audios, they are very hard to understand. Okay. Sometimes the meaning are ambiguous, and also they tend to be large and fast because compared to text or structured data that are generated by machines, okay, um, images or video size are really large, and you need a really good processing unit to understand what this image is about, to understand what this video is about, what I'm talking about, okay, and these content are being generated all the time. Just take a look at TikTok videos, all right, a lot of nonsense going on. A lot of people try to get content all the time, and in order to to manipulate them, to understand them, to get any useful insight from them, are very challenging. Another challenge is that they are very difficult to integrate. They are very difficult to put into the context and integrate with other kind of data. Another kind of data that are actually closely related to machine-generated data are data collected by organizations. Organizations produce data all the time as part of their businesses. Commercial transactions, money transactions, stock exchanges, electronic medical records. These kind of data are generally highly structured because they are generated by programs, okay, and they are stored in traditional relational database management system, okay. Well, you might say that, hey man, but the data that are generated by, for example, cashier in 7-Eleven, there are people that scans barcode and people picks the products and everything. But yes, you use people to collect data, but the data itself are structured. The barcodes on the product are standardized. You know what this barcode represents which product, and you also know right from the get-go that if he scanned the same barcode again, it means that the customer buy the product twice, right? So the challenge is not lying on how to read or manipulate the data. The challenge is on how can you be sure that the data are collected properly. There could be still, human errors, okay? And of course, as I mentioned earlier, there could be some issue called data silos. Data are being stored in different places. Each department collect their own data and they are not sharing among each other. Okay. And maybe it depends on the company policies or some external regulations or limitations that do not allow data to be shared. Okay. And sometimes nothing is wrong with that, because if the data is sensitive, like personal data, the first policy should be protect first, keep them safe first, then we select what we share later. Before you can even start analyzing your data, you need to prepare your data first. You need to make sure that they are in the appropriate structure, okay, so that your tools or your analysis platform can process them. Preparation consists of mainly two steps. First, exploring your data. You need to look into the data and try to understand the nature, quality, and format of your data. Exploring the data means that you really have to look into your data, you yourself, not the machine, human. Okay, data scientists usually look at the data. Okay, how does it look like? What are the structure? Okay, is there any missing data? Okay, is there any data that are misplaced, mistyped? Okay, or the input is correct or not? Okay, and then once you understand the nature of your data, you can start pre-processing your data. That is to clean your data, to filter the data, start modeling, and then maybe translate your data into specific format that your tools, that your libraries, that your platform understand. We will discuss all this process, cleaning, filtering, modeling, later down the line. But let's discuss the first thing first, data exploration. Okay, this is the process where you gain some understanding of your data. Okay, first, what are the content that are contained in your data set? Okay, what are the ranges of data? It is from year 2001 to 2022. Okay, or maybe what are the common behavior or values that are stored in your data? Correlations between the fields, between parameters, the trends. Okay, and maybe some error or outliers that is contained into contained in your data. Okay, for those you don't know, the outlier is something like this. See, the trend of this data goes like this, and there are some few dots, few data points that look like this. This could be an error, maybe error from data recording, maybe something that are interesting, maybe something that's not interesting. For example, you are studying the average life expectancy of a population. Okay, normally life expectancy is being around something like 60 years old, 70, 80, and then some guys, okay, or some ladies aged 100 or more than 100. Is it okay? Can you say that the maximum life expectancy of human is 120 if you have like one or two guys that can live more than 100 years? All right. So this is the thing that you need to look into. Most outlier could be neglectable, but some could provide you special insight in your data. And this is a very important step. Okay, do not start your analysis unless you overwhelm yourself with data first. You need to skim through CSV file, text file, Excel file. You need to immerse yourself into your data. You need to have a look. What are the values? What are the potential values? What are the ranges of values, 1 to 100, or year 1 to year 2, or something like this? You need to understand. You need to get some feeling first. Okay. You need to have some initial intuition of your data before you even start analyzing it. Sometimes simple statistics would help you gain some insights. For example, mode. Mode is the value or values that occur most frequently in your dataset. In other words, it is a value that appears with the higher frequency. Okay. Median is the middle values of a dataset when it is ordered in the ascending or descending order. Half of the population is below the median value. Half of a population is above the median values. Now, the mean, quite simple, is the average value. You guys know this. Yet, mean does not work well in some dataset, especially when they are skewed. Let me get you an example. Considering the scenario where I am analyzing student data, okay, for example, the scores of the student in big data analytic class. And the mean, okay, is say 25 out of 40. Okay. With this observation, I would say, okay, some student, okay, might do be worse than 25. Some student might do better than 25, and 25 is the average value here. So this is what we call the Gaussian distribution. But if I take a look at my data, the raw data, I may see something like this. Okay. This is my y-axis, I'm sorry, okay? This is my x-axis. So it could be that most of the students couldn't do anything much, and only few students can do a lot, okay? And these students pull the mean towards the higher score. That could happen. Or another scenario, okay, I have two axes of data, and the score look like this. You have the students that cannot do much, and some students that can do very well, okay, and the mean is somewhere around here. That happens too. So in this simple example, you see that unless you really have a look at your data, you will never understand, you will never know the true nature of your data, okay? So please explore your data thoroughly, okay? Make sure you have some intuition of your data before you start analyzing it. To explore and understand our data visualization could help. Data visualization is a practice of representing data or information visually through graphical or visual elements such as charts, diagrams, graphs, or maps. This involves converting complex and abstract data into visual representations that are easier to understand. The data visualization helps uncover patterns, trends, relationships, and insight that might not be apparent in just viewing raw data alone. Here, we have heat maps, okay, contour, we have scatter plot, and we have network. Scatter plot shows discrete data points on a plane. In this image, the points are on a 3D plane. We can use network graph to explain relationships between data items, okay? And contour right here refers to line or curve that represent constant value of particular variable in two-dimensional space. This line, we call it a contour line. Contour lines are commonly used to depict shape patterns and changes of values of continuous variable across the surface or map, okay? For example, here, it means that the entire area here has the value of 0.04, okay? And the entire area here has the value of 0.035. In here, we have heat map. Heat map is a graphical representation of data where the values within two-dimensional matrix are represented using colors. In this particular example, our data are related to specific location. So, I mean, the wave at this point is this much, the temperature of that point that much. Set of data that are related to specific location on Earth, we call geospatial data. We actually have tons of charts in our arsenal to represent the data the way we like. You can select the one that is most suitable for your need. For example, all right, let me zoom in. Histogram. A histogram is a graphical representation that organizes and displays data distribution by dividing it into interval or bins along the x-axis and showing the frequency or counts of data points falling into each bin at the height of the corresponding bar on the y-axis. Okay, right here. Next is tree map. A tree map is a data visualization technique that represents hierarchical data using nested rectangles. All right, the size of each rectangle corresponding to a specific attribute or value that you are interested in, allowing for the comparison and exploring of hierarchical relationship between the data. For instance, this is the tree map that displays the area of states. Here you can see that Russia is the largest, okay? We have the US and Canada, we have China and Brazil. These are the 5 countries are the largest ones, okay? And then we have Australia and we have India. And not just the size uh, of the data items right here. If you like, you can divide China into smaller pieces. Maybe each province of China can also be divided. Okay, so you're gonna have like a large border dividing China right here, and each province in China may have a box, okay, dedicated box here, indicating how large the provinces are. The states here in the United States, you can divide them into 50 smaller boxes, okay, and then each area or each box represents the size of each state. So you can drill down further and further and further. Next, we have bar chart. All right. I don't think I have to explain bar chart. It is a chart that uses rectangular bars of varying lengths to display and compare categorical data. And now we have box plot, also known as box and whisker plot. It is the graphical representation of distribution of dataset. Okay, it displays not just the size or frequencies or the amount of data, but it displays a summary statistics of that data, such as median, quartiles, and outliers. The box, okay, each box represents the interquartile range or IQR between the first and third quartiles, with the line inside indicating the median of the data, and the whisker that extends from this box, okay, represents the minimum maximum values within the certain ranges or specific criteria, such as the standard deviation, maximum values, minimum values, or even outlier points. And then we have dendrogram. Okay, as you can see here, dendrograms look like a tree, a large tree. Dendrogram is a tree-like diagram that illustrates the hierarchical relationship of and clustering of objects, similar to the tree map. Okay, it shows different elements that are grouped together based on their similarities and allow for identification of cluster or subgroups within dataset. One example of dendrogram is the biological taxonomy, specifically the classification of species. A dendrogram can be constructed to illustrate the evolutionary relationship and groupings of species. In any case, with all those data visualization tools, most of the time you just have to dig through the tables, through the actual data. It's either Excel, database, or maybe database schema. Here you have ER diagrams explaining the schema of database, all right? And I'm sorry, guys, that's the part of the job. The data that you have access to may come in different size and form, okay? And from many sources, many formats. They also come in different qualities, inconsistent values, duplicate records, missing values, invalid data, outliers. The scenarios that I always encounter are incorrect input. The data structure, okay, the schema of the data may be well defined, but the user themselves, okay, the guy that input the data, use it incorrectly. For instance, the email field, okay, the user, instead of just typing in email, they might just type extra addresses, extra description of the data, okay, or maybe telephone number, or maybe telephone number fields. The user put email instead, okay. Well, you need to understand that when a user types the data into the system or input the data into the system, especially when they haven't thought about big data or data analytic or data processing, they just type, okay, because what they see on screen, they can understand. Another example, please take a look at this. This is the actual data, okay, that I took from one of the dataset that I used to work on. It is dataset on the juvenile correction system, okay. So here, you don't even have to understand what this field is about. But have a look at this. Some of them say ใช้มาตรการเช้ามากลับเย็นกลับและวางเงื่อนไขผู้ประพฤติ okay some of them says มาตรา 132 วรรค 2 okay and then 132 wall 1 right here okay and you can see here this and this and this and this are pretty much the same concept okay whoever understand this would understand all this okay but some of them it is more elaborated ใช้มาตรการมาตรา132แห่งพระราชบัญญัติศาลเยาวชน2553 alright so it is more elaborated some just say release or maybe contain or detain alright some of them say well just train them this is the data that records the verdict of the juvenile courts so it's basically it records the verdict of rulings. It is like this because the UI of the program that records these verdicts, okay, just allow free text. So basically, the user can type anything they like, okay, but it works because they understand when they see this on UI. Okay, the user that type in this, or the user that reads the information on the screen, understand because they understand the entire context. But if you want to process the data, okay, how many people got released, how many people got detained, why they are detained, okay, or what kind of rules or regulations are corresponding to these verdicts, you cannot do that easily. And if the developers or the programmers do not restrict how you type in the data, okay, the data might not be correct. For instance, if you are going to develop the UI, okay, and within your UI, the user can type in email addresses. Email address has specific format, so you need to have like the your address something at some address like something.com. And if the user doesn't type the at and the dot something in the end, then you could detect that, hey, this is not an email address. This is not a valid email address. Okay. Or maybe you can go further saying that, okay, you can input Thai name and English name, and you can detect the language on the go. All right. These kind of restrictions or limitations, okay, help you collect the data more properly. And you should embed this every time when you design the UI, when you develop the UI. All right. So the mindset of using, interpreting, collecting data, okay, so that you can use later, you can analyze them later, has to be built in to the everyone involved in the process, from the data analyst, okay, to the programmer, and also to the user. However, no matter how you prevented them, okay, the data still come in dirty, which means that they contain a lot of errors. You need to clean them first, and then after you clean them, you might need to transform them into the format that you are using. The process of cleaning data is the process of getting rid of all these errors. Okay, you detect whether you have duplicate records or not. You detect which data records that contains missing values. Okay, you detect which records contain the data that are invalid. For example, the email address that are not stored in the correct format. Okay, or maybe the values that are inconsistent. For example, age. Okay, of the student, but you type in 0 or negative values, or even university student who has like 2 or 3 years old, that wouldn't be possible. Okay, this kind of thing, this kind of inconsistencies and outliers, once you has to be taken care of. All right, and this is a process of data cleansing. Since we are in the topic of user input, let us have a short detour and discuss Thai encodings. Thai language is one of the worst languages to deal with in terms of data manipulation. No, not because it is difficult to read, difficult to understand, or difficult to tokenize, but it is because we have four main character encoding systems. And if you ever seen alien characters like this when you open a text file, this encoding mess is the reason. So, what is character encoding? Character encoding refers to a system or method used to represent characters, symbols, and text in computer systems. It defines the mapping between numeric values, like binary values, and the corresponding character to store and display them on the screen. ASCII code is one of those encodings. Now, let's discuss Thai encodings. First, we have the TAS 620. TAS 620 stands for Thai Industrial Standard 620. It is an 8-bit character encoding standard for Thai language. It was developed by Thai Industrial Standard Institute, or TISI, in 1990s, and it is primarily used in legacy system or older Thai text-based applications. And then we have ISO 885911. Okay, the ISO 8859 is the standard of character encodings. All right, the -11 indicate that this is the standard just for Thai encodings. The ISO 885911 is similar to the TAS 620 encoding and shares same character mappings between the binary numbers and the Thai characters. It assigns the numerical values from 0 to 255 to each Thai character, along with the subset of Latin and punctuation characters. The ISO 885911 encodings were designed to ensure compatibility with the Thai TAS 620 encoding while conforming to the international ISO 8859 series of character encodings. This allowed Thai text to be exchanged and displayed correctly across systems that adhere the ISO 8859 standard. However, it is important to note that the ISO 8859 is an 8-bit character encodings, which limits the ability to represent wide range of characters from the different scripts and languages. As a result, most modern computer systems use Unicode-based encodings like UTF-8. What is Unicode? Unicode is a universal character encoding standard that provides unique numeric character point to every character across all languages and all scripts that we know. The number of bits to store each character, unlike ASCII character that have only 8 bits from that could represent the values from 0 to 255, all right? The number of bits in Unicode is so large, it is enough to store the characters of all languages that we use today, and also including the dead ones like Egyptian hieroglyphs. Yes, the one inside the pyramids. Today, we don't use TAS 620 and ISO 8859 anymore. We move on to Unicodes because it is so large that contains all characters that we use today. This makes most computer systems in the world much more compatible with each other. But then we have this devil Windows 874. Windows 874, also known as Code Page 824 or Windows Thai, is the character encoding system primarily used for representing Thai language in Microsoft Windows operating systems. It has been released, okay, it was released in 1992 along with Windows 3.1. Surprisingly, after 30 years, it is still in use today in all Microsoft products. In fact, Excel still uses Windows 872 or 874 as its default Thai encoding. But what is the problem? The problem is if you keep using Excel, all right, you write something in Thai, store it in Excel file, and use Excel to open the file, it wouldn't be any problem. Okay, if you restrict yourself in Microsoft ecosystem, you wouldn't you wouldn't see any problem. There wouldn't be any problem. But once you start exchanging your data with other computer system, then there will be a problem, because all modern system today, all right, use Unicode as default encoding. And this standard, the Unicode standard, indeed includes Thai characters, but not on Excel. Okay, if you use Excel to store a text file, all right, that text file will be encoded using Windows 874, and that cannot be opened directly using other systems. Okay, the data cannot be um, immediately imported to some other database systems, and vice versa. If you use Excel to open text files that contain Thai characters that are generated by other systems, you will see funny alien character like this, because Excel assumes that the text file that is open will be also encoded in Windows 874. This makes Excel incompatible with other data manipulation software or databases or any software outside of Microsoft ecosystem. To be fair, Excel provides an excellent tool to export and import data to and from UTF-8, but the users must be aware of different encodings and must explicitly import and export data to and from UTF-8 standard. Okay, let's come back to our topic. Data cleansing. Data cleansing is a process also known as the data cleaning or data scrubbing. It is a process of identifying, correcting, removing errors, inconsistencies, inaccuracies, or anomalies within your dataset. It involves detecting and addressing issues like missing values, duplicate records, incorrect formatting, outliers, and other kind of data qualities issues. The goal of data cleansing is to improve accuracy, reliability, and inconsistencies of data to ensure the suitability of analysis, reporting, and decision making. All right. The process of data cleansing generally involve several steps. First, you need to have a look. Okay, you need to inspect your data first. Data set is carefully examined to identify potential issues such as missing values, inconsistent formats, outlier, and duplicate entries. Once you see these issues, you need to start handling them. Okay, first you can handle your missing data. Strategies can be employed to address missing data, like imputing values based on statistical methods like finding average, or simply erasing the records that contain missing data. Handling missing data might require a lot of domain knowledge to determine what data should be, what kind of data should be replaced. Okay, if you have some missing values, what can we replace these missing values, or should I just erase the entire record altogether? Next, you need to identify the invalid data. All right. In this process of data validation, you need to check the data for the conformity to the predefined rules or constraints. This includes validating data types, ranges, and relationship between variables to ensure data integrity. And next step is to remove the duplicates in data. Duplicate records or entries are identified and removed to avoid this double counting and maintain data accuracy. This step is particularly important when merging or consolidating multiple datasets. What do I mean by that? What I mean is, if you have data from different sources, okay, sometimes they just contain the same piece of data, so they are duplicates, and you need to identify those duplicates and remove one of them, or maybe you merge them together. Well, sometimes when you pull records from two places, right? Imagine you are trying to construct this uh, course data, and you have the data, student data from this course database, and you have another one. We have another set of student data that store the GPA, okay, across the entire program. Then once you have the data, two data items from two places that represent the same student, some of them may intersect, okay, maybe the name of the student, the ID of the student intersect, but the GPA and the grade points might not be the same, okay. And this is the thing that you need to handle when you pull data from multiple places. Talking about that, the data has to be transformed or standardized to a consistent format, a unit, especially when you pull from many places. Okay, this may involve converting this format, normalizing text case, or standardizing units of measurement. It could be inches, it could be centimeter. Okay, or date format is also a very interesting issues, because different computer system storing time and date differently, and you might want to handle outlier as well. Outlier are the extreme or anomalous values, okay, and sometimes these extreme values, okay, is actually part of your data. Sometimes it's just error, okay. Then you need to consider whether you're gonna remove them or you keep this data in your data set. Lastly, very important, I didn't write it down here, but also very important step, you need to document your process. All right, you need to know what you have done, you need to know how you have done, and you need to write it down somewhere. Okay, because when you want to trace your step, why is this data items missing, how can I convert this date from this system to other system, how can I convert Thai character from this system to other system, you need to be able to repeat the steps. Otherwise, when you have new version or new set of data and you want to repeat the previous step, you cannot do it anymore. All right, you need to always keep records of what you have done. Anyway, to summarize, data cleansing is a crucial process because it ensures data quality and it enhances reliability of analysis and decision making. And if you want to publish your insight or knowledge somewhere, especially in respectable scientific journals, you need to explain all your data cleansing steps. The next activity is data transforming. Data transforming, also called data wrangling or data munching, it is the process of transforming and mapping data from one raw data form into another format with the intent of making it more appropriate and valuable for a variety of downstream purposes such as data analytics or visualization. Examples activities in data transforming includes feature selection, data scaling, data transformation, and data manipulation. Feature selection is a process of identifying and selecting the most relevant or informative features or characteristics from larger dataset of larger set of variables or features in dataset. It aims to reduce the dimensionalities or the number of features, to improve model performance, to eliminate the redundancies, to eliminate the irrelevant features. The next activity is data scaling. All right. Sometimes values come in different scales or units. For example, inches, centimeters, or Fahrenheit or Celsius. The process of handling such differences is called data scaling. Data scaling is also known as feature scaling or normalization. It is a process of transforming numerical variables in the dataset into a consistent scale or range. It ensures that different variables have comparable magnitudes, preventing certain variables from dominating the analysis or modeling process due to their larger scale, enabled fair comparison and accurate calculations when you manipulate or when you study or when you analyze your data. For example, when you compare to stock values, okay, when you say Apple stock drop $10, you could be like, oh man, they're dropping $10 per share. That's huge because the other companies drop only like $1 or $2 per share, but it might not be a fair comparison because $10 for Apple might be, only like 1 or 2%, okay? But $10 from other companies might be 5 or 10%, or even 20%, depending on the stock price at the time. So therefore, you might want to consider exchanging in percentage instead. And this is the process of normalizing. So you want to compare two things, you need to compare them into the same scale. Next one is data transformation. Okay, data transformation is a process of changing representation or domain of data to make them easier to compare. Data transformations involve the application of mathematical or statistical operations to modify the structure or value of the data. This is done to address issues such as the nonlinearity or skew distribution, and to satisfy assumptions of statistical model that you want to use. The last one is the data manipulation. Data manipulation refers to the process of altering, reorganizing, or transforming data to extract meaningful insights or to answer specific research questions. Let me talk a little bit more about data scaling because I find this is very important. Okay, sometimes people kind of play tricks with the data, showing the data in a way that is more scary or misleading. Okay, so you need to be careful how to present your data in a correct way and also how to interpret the data from other people as well. All right. Data scaling or feature scaling is a process to standardize ranges of the feature, also known as normalization. Okay, the easiest way to do the normalization is to use the min-max normalization. So that you have value x, this is your original values, okay, and you want to kind of convert that into a specific scale, okay, to in the normalized scale. You can have this. You're gonna obtain the maximum values that x could be, or the maximum values in the data set, okay, and the minimum values of x in the data set, and then you find a difference between the x, okay, and the minimum values of x, which is basically you want to see where x actually is in this scale from max to min, okay, and this scale, okay, the transform scale here is your x prime. This is your normalized values, or you can use percentage. It works the same way, okay. Percentage count from 0 to 100. To see why do we need to do scaling or normalization, let's have a look at this graph, okay. This is the cumulative COVID cases, all right, in January 2022. This is the peak of COVID before the countries opened border again. They are still right that time. I think the border opened, if I remember correctly, around February or March last year. All right, so this is pretty much the height of COVID. Take a look at this. In United States, you have, I think, around 70 million people that has been infected with COVID, okay, followed by India. followed by UK and Germany. Okay, what was the fourth one? Spain and Italy. Okay, follow close by. Now, as you can see here, if you take a look, have a look at this number, you're gonna be like, oh, the US, they are not doing so well, right? And India as well, man. India is like 30 million people and 35 million people. Okay, this is like twice more than the UK. All right, a lot of people. But now, if you have a look at the other chart, this one, the UK grow faster or even higher than the US, and India is nowhere to be found. Okay, well, yes, it can be found here after Thailand. What is the difference between the two charts? The first one is the cumulative confirmed cases. So basically, how many cases do we have so far? But this one, the cumulative confirmed cases per 1 million people. So out of 1 million people, how many have been infected so far? See, India has much larger population compared to other countries. That's why the 35 million are not that much, even lower than Thailand. The UK, for instance, okay, the UK, they have around, I don't know, 15 million infected cases, okay, or known cases, but per 1 million population, 20% of them are infected. It is large, okay? Well, but the US, they are not doing well in both charts, but you know what I mean, all right? So, therefore, when you want to compare, in this particular example, okay, to compare how severe the infection is, okay, you need to compare by 1 million people to address the differences of the population size. And not just this, uh, when you compare data, stock market prices, healthcare system, you need to make sure that are we talking on the same scale? Because if I want to narrate the value in a way that India and US are doing so bad in COVID prevention, I could do that using this graph. But if you just believe this graph as is, you're gonna be like, okay, looks so bad. This in these two countries, other countries they're not doing so bad. But in fact, okay, when you compare with some when you compare values with the same range, which is per 100 per 1 million people, you will see kind of better picture. Another kind of manipulation is that China, you might expect China to have a lot of infections, right? Because they have a lot of people. But no, China is really nowhere to be found. Literally right here. Zero. Zero here, zero there. And you need to be aware that it might not be because China are doing so well. Maybe they hide the number, or maybe they are doing so well because they are actually closing down all places in the country. All right. So all in all, when you want to see data, when you want to see charts, okay, when you want to also when you want to present, you need to understand that you understand the context correctly. When you perceive data that are presented by other guys, you want to make sure that does it make sense, does it follow the context, is it compatible to what I know, okay, or my background knowledge or not. Now that you have collected and prepared your data, let's start analyzing your data. Analyzing data is the process to obtain knowledge or insight from data. All right. In other words, you're trying to understand the data and maybe some phenomenon that are hidden in the data. All right. In our context, data analysis is to apply model into the data. All right. And there are several analysis techniques that can be applied, can be used on our data. These are some of the example techniques that we can use to apply on our data. First, classification. Classification is the process of classifying data items into predefined groups or classes. Another one is regression. It's the process of estimating relationship among variables. And clustering is to organize data items into undefined groups. Association analysis is to find hidden rules that associate different data items together. And then we have graph analytics. It is to use graph to present relationships among data items. Now let's have a look and let's have a look at these techniques in detail. First, classification. Data classification is the process of categorizing or organizing data into predefined groups or classes based on their characteristics, attributes, or labels. Together, we call them features. These classes could be yes, no, like, dislike, yellow, or orange, or even identify objects in images or videos. Data classification involves applying algorithms or statistical techniques to train the models that can automatically assign new data instances to appropriate classes based on patterns or features derived from this training data. And the algorithms that are used to do data classifications are usually machine learning algorithms. Data classification had been used in many fields, including pattern recognitions, image analysis, video analysis, document categorization, fraud detections, and to make predictions or decisions based on identified classes or categories. Regression analysis. It is a statistical technique used to model and understand relationships between two dependent variables and one or more independent variables. It involves fitting a regression model to the data to estimate the quantitative impact of the independent variables on the dependent variables and to make some predictions. Regression analysis has been used in many applications for quite some time. For example, sales forecasting. Regression analysis can be used to predict future sales based on historical sales data, marketing expenditures, pricing information, and other kind of factors. Regression analysis can also be used in demand analysis as well. So we can employ regression to understand the relationship between demand for a product or service and various influencing factors. In finance, regression analysis is often employed in finance to examine the relationships between variables such as interest rates, inflation, stock prices, or company financial metrics. By analyzing historical data and building regression models, financial analysts can make predictions, evaluate risks, assess investment opportunities, and develop some financial strategies. It can also be used to evaluate employees as well. Regression analysis can be used in human resources to assess relationships between employee performance and factors such as training hours, years of experience, education level, and performance feedback. And it can also be used to predict weather as well. Clustering. Clustering is a data analysis technique that involves grouping similar objects or data items together to create a distinct cluster or categories based on their similarities or proximities in multidimensional space. It aims to discover hidden patterns, structures, or natural groupings between data without any predefined labels or classes. Clustering algorithms identify clusters by maximizing intra-cluster similarities and minimizing inter-cluster similarities. What it means is the values of data points within the same cluster should be similar. The values of data point in different cluster should be less similar, allowing for exploratory analysis, data segmentation, and understanding underlying structure or relationship within the dataset without predefined classes or without the background knowledge of the data in the set. Association analysis. Association analysis, also known as market basket analysis or affinity analysis. It is a data mining technique that seeks to discover intersecting relationships or associations among items in a dataset. It examines the co-occurrence or co-purchase patterns of items in transactions or dataset to identify frequent item sets and generate association rules accordingly. There was a study that analyzes the purchase records in a supermarket. Right? In that study, they found that baby diapers and beers are usually bought together. And they were like, why does it happen? Okay. So they went out and tried to figure out what's going on there. As it turned out, when dads are sent to do shopping or to fetch baby diapers, they tend to fetch some beer for themselves as well. Graph analytics is a branch of data analysis tools that focuses on extracting insights and knowledge from data represented as interconnected nodes and edges, forming a graph structure. Graph analytics techniques leverage the graph theory and algorithms to study relationships, patterns, and characteristics within the nodes in the graph. It allows for the exploration of complex networks, identification of the nodes, detection of communities or clusters, analysis of connectivity, and prediction of outcomes based on structural properties of graphs. It finds the applications in diverse fields such as social network analysis, financial interconnectedness, fraud detection, supply chain optimization, recommendation system, network securities, and also bioinformatics. By examining the interconnections between entities, graph analytics enables deeper understanding of the underlying structure and dynamic of the systems. Let's have a look. This is the cartography of Wikipedia pages around the keywords data visualization. Okay, and it is running on the Earthware Retina. Okay, you can have a look at the tools by yourself later. It is quite interesting to see. All right, I will leave a link down below in the description. But take a look at this one first. This shows the connections between articles in Wikipedia, okay? And these articles are related to data visualization. Showing you this, it is super static, okay? But if you take a look at the original website, you can pinpoint what each node represents, which article each node represents, and you will see immediately the connection between the interested nodes and all other nodes. Okay, and from there you can study relationships among multiple nodes. Okay, so we have introduced a lot of now we have introduced quite a number of analysis technique, but which technique do I need? How do I actually conduct the analysis process? Okay, there could be a few things, okay, a few simple steps to follow. First, after you collect and studied and prepared your data, you select the technique, the analysis technique that match your data and the question that you have. Then you start building the model using the collected data and the algorithm or the method that you selected. Okay, and then you evaluate the model. You check whether the model explains the data characteristic. Okay, if the model does explains the data, then you might really have your insight. Generally, the data are divided into training set and test set. You build your model in the training set, and then you are using the model to evaluate the model in the test set. Okay, if the evaluation perform well, then you might already have insight, and the insight is explained by your model. But sometimes you don't even need this algorithms or sophisticated models. Okay, sometimes you just want to present facts. What do you mean? What do I mean by representing facts? Maybe you just want to present the average GPA of the student that attend the data analytic course. Maybe you just want to present the show the average height of the student, or maybe some demographic informations like the average life expectancy of Thai population, okay, or maybe COVID cases based in 1 million people, okay, something like this. You don't need model to explain this kind of thing. You just have to figure out how to show them in the proper way, like which data visualization tools you use, how can you normalize the data, and so on. So you have done some data analytics, okay, and you want to present what you know. You know that, okay, you have the model that explains the phenomenon or characteristic of your data. That is, you have an insight, or maybe you want to explain the correct characteristic of your data directly, okay. How should we do it? Okay, the result should be put into some kind of report so that the other people, okay, the audience, your executive, your boss, or even you can have a look at your insight, okay, can have a look at the result. But how should we do it? First, you need to identify your results first. You might know or learn a lot from your data. Okay, you have done 6 months of experiments, 6 months of analysis, and you have, like, 3 or 4 pages of insights. You need to first identify which one is more important than other ones. Okay, which one are most valuable, and you might want to present them first. And you also need to compare your results to your success criteria that you have set when you at the beginning of the project, to make sure that whatever you learn, is it successful or not. Okay, results could be negative or inconclusive. For example, I have worked with the organization, okay, that gave us 10 years worth of data, and they asked us to do something to learn some insight that, okay, I want to know this. Can we know this from the data that we provide to you? So it took me several months to go through all this 10 years data, and it turns out that the data that I collected are pretty much worthless. Well, they are not worthless because they are useful. It's a piece of data, right? But they are worthless to the question that they ask, mainly because the information that are crucial to answer that question are not included in the data. Well, that's unfortunate, but that happens. Okay. That is why we need to set up the question and the success criteria beforehand, so we know that, okay, our project or our method, okay, answer the question or not, or whether the project is successful or not. In any case, the tools that you use to analyze your data can also be used to present your result or insight as well. This time, you are showing the data product. That is what you learn from your data, not the data itself. Okay, you can use heat map, contour, or maybe just bar charts to explain your results. Let's have a look at some report example. All right, this is the report of the fake news analysis that we did with Bangkok Post, okay, back in 2021-22. Okay, it is the report about fake news, okay, related to COVID outbreaks. This is the COVID outbreaks, wave one. Okay, this is second wave, and it is third wave of COVID outbreaks. And the little dots right here indicating number of articles talking about COVID and the outbreak. All right. And the gray one is represent the number of articles that are neutral, that doesn't talk bad. I mean, that's just not fake, right? The this one, okay, the purple one indicates the misleading content, okay, and the red ones indicating false content, okay. So these two are considered fake, right? And as you can see here, in the first wave, we have a lot of content talking about some event, some COVID event, okay? And this also, the second wave have some of them, third wave has some of them. But in this simple chart, you can see different aspects of the same data. First, the frequencies, okay? And the relative amount of misleading and false content against all contents right here. And then not just the frequencies, all right? You can also see the time span of this wave, okay? And this discussion is much longer than this one, and it also longer than this one. Although this wave 3 span only from April to June, okay, the same year. This one is from Jan to July. But this is shorter, but the why it has been talking, why it had been discussed, the number of frequencies are pretty much the same as this one. Okay, so as you can see here, you can select the chart or the tools to represent your data or represent your insight based on what you want to tell your audience. And here are some examples of data visualization tools. Well, this is actually, it looks like a long list, but it's actually very short, okay? If you Google data visualization, you're gonna see a lot more tools. Some of them are commercial tools, some of them are open source, some of them are free to use tools, okay, kind of web-based application where you can use for free, but you don't get to see the source. Some of them just open source, but you need to install or compile or somehow deploy on your own system. All right, we have Google Charts, we have Metabase, we have Raw Graph, D3, okay, we have GNU Plot, we have Retina, okay, we have seen Retina already before, okay, we have some classical tools like Excel or R, all right, Rapid Miner, I use it a lot as well, okay. We also have Vega and of course Python, which is the programming language that you can use to manipulate data. Now, last step of your data processing, data manipulation journey, okay, you're gonna act upon it, right? Once you learn from your data, once you have the insights, your knowledge, you can improve your business with them. Change the sales strategy based on customer preferences, redesign the shelf according to corresponding products, improve the regional budget distribution, okay, or maybe some real-time actions like real-time product recommendation, targeting online ads, or something like this. But anyway, you learn from your data, okay, you acquire, you prepare, you learn, you act, okay. Not just that, you need to keep repeating the process. Everything goes in a loop. Remember, you acquire, you prepare, you analyze, you report, you act, and then you acquire data again, prepare again, analyze, and report data and act upon your knowledge again. That's it for today, guys. All right. It has been a very long session. It took me more than 8 hours to complete this video. Okay. I hope you enjoy. It took me really quite a while to do it. And I would appreciate the like. Okay. But like is not very important, really. I would appreciate that you finish your video. Okay. And we will see each other again in the next session. And yeah, I will just drop the updates on the video in our usual Discord channel. That's it. Thanks a lot for joining me today. Bye.